Hi, everyone. We are very excited to have you all here today and launch the first episode of our new podcast called AI Simplified.
I'm Allie.
I'm Phil, and we have Amjad.
Hi, everybody. Glad to be here.
And we're your podcast host.
Yep. And we're here to help simplify AI.
Before we get started, Amjad, why don't you give us a little background about what inspired you to create this podcast? I know it was collective effort, but I know you had an epiphany of why we should do this. So,
Yeah, no, thanks, Ali. I've been studying and practicing AI for the past 30 years. Very passionate about the topic. Certainly, I mean, in order, for somebody to invest 3 decades of your life, it has to mean something, right? Uh, Now, my passion has been how to solve meaningful problems with AI and how to practically apply it today without, large budgets and with all the practical limitations that most businesses are in. And now with COVID, the need for such innovation and optimization, have further increased. So I just had this idea of how to present concepts in a very simplified way, but not simplistic, not at the loss of the depth of the concepts. And use this first principles thinking, which is uh, a bottoms up thinking method where you base the conversation on some scientific principles and build up from there and not some top down approach from cloud to coming to the grounds. But so so that's what my excitement is for uh, this podcast, that people will find it very useful, relevant, and applicable to their day-to-day work lives. Whether I'm a listener to this podcast, whether I'm a business user, whether I'm an executive, I'm trying to solve resource allocation problems within my company, within my supply chain, whatever it is that I'm trying to do. So I hope that that business audience will find this podcast very useful, and we will demystify a lot of these topics and hopefully be practical about it. That what are some of the right questions to ask and things to consider or actions to take, that sort of thing. But those are my thoughts, Sally.
I love it. Thank you for sharing. And just a little background, we know learning happens in different formats. So this podcast will not just be audio. And if you want to participate in our live events, you're welcome to. And there'll be, like today, there'll be opportunity to engage and participate. But we will also have episodes on demand after live events. We encourage you to take part today. But with that, Phil, what are we talking about today?
Yeah, thanks for asking, Ellie. Today, we're going to talk about the core principles of how to simplify AI through a human-centered approach. We'll chat about what that is, what human-centered AI is, what it can do for your business, and how even it can provoke ideas for new businesses. The three of us are very into the concept of exponential thinking, and we'll cover that with a focus on how humans and AI can work together.
I'm excited. So we hope you all are excited as well, and this topic is exciting for you. We welcome interaction. So the whole purpose of having a live event is so that you can ask questions as we are talking. This is meant to be interactive. There'll be some cool exercises that we can all associate with AI and learn a little bit together. So feel free to post questions directly into the Zoom chat, and we'll do our best to answer them as we go along. If it's not fitting, we'll follow up at the end. But this is intended to be interactive. So please comment or ask questions whenever you have them. And with that, let's get into it.
Great. So yeah, I'm glad in the spirit of this podcast, defining in very simple terms, let's talk about what AI is, both from a theoretical perspective and also in practical applications.
Yeah, no, absolutely. And then Phil, if you maybe bring some of our slides up. So I think that's it. That's good. Thank you. So look, one way to think about AI, if there is one thing that we can remember from this conversation, is competence without comprehension. I'm going to unpack that idea a little bit for everybody. And now this first principles thinking, we will build it upon the big ideas that have led to, in my humble opinion, the development of the most recent AI phase or wave that we are in. So let's start with Darwin's big idea. And his big idea is that in order to make a perfect and beautiful machine, like a mammal's body on planet Earth, it's not required to know how to make it. And what he meant by that was that a lot of uh, trial and error and learning and some search through a design space went for a long period of time to bring the sentient conscious machines today, just using Darwin's lingo, calling us sentient conscious machines, also showing respect to our machine colleagues. But that was Darwin's really, really big idea. Turing, in the 40s and 50s of the 20th century, last century, his sort of big idea, which kind of started the whole computing revolution, which AI at some level is just an advanced form of computing, right? So his big idea was, in order to make a awesome computing machine, it is not required to know what arithmetic is, right? So that was the genesis of the computer science. And back in Turing's days, computer was a job and people performed that job, right? So people maybe who studied mathematics, they performed that job. And his whole concept about Turing machines and how fundamentals of computer science got started was a computer doesn't need to know any of that, and yet it can figure out all of that good stuff. And that started the modern computing revolution. So another big idea from Polanyi along the way came that we as people know a lot more than we can tell. So we have a lot more tacit knowledge. We have a lot of competence on many things. But then if you ask how exactly, what is the algorithm? We would be hard pressed to say, but we can just do, right? So we have that competence that we bring to the table. So, okay, so now you combine it all. So then the AI community's big idea, Phil and Ali, is that, okay, in order for us to write a software, we don't need to know how to write it. Or in order to solve a problem, we don't need to know how exactly and precisely to solve it, which is a way to say that just by making a lot of observations of how that problem has been solved by others, or observing others, how others are doing certain things, AI can learn how to do that. without having to be expressive about that. So I think that is that big idea. So if again, there's one thing that we in this podcast series that we can think about is this competence without comprehension. So if I just maybe go on for another few minutes and unpack a little bit more. So then, if we want to think a little bit further about then artificial intelligence, this whole competence without comprehension journey. So one practical way to think about the AI, as I even just spoke, is it's a new way of writing software. So in good old days, 20, 25 years ago, or even today, for many things, the way software is written, you ask for requirements and you do your requirements documentation and all that fun stuff. You specify, right, the rules, the logic, explicitly stated, and then you use different methods, methodologies to build a software. Let's call that a classical way of writing software, still very relevant today. But what AI and machine learning enables you to do is that you don't have to specify those instructions, those logic. If you just have a lot of data to observe from, AI can learn that logic implicitly. So I think that part. And then just from a theoretical part perspective, if I were to just make a quick comment is what these AI systems are doing, whatever it is that they are observing, they are making a model of their reality. Now, why do we make models? So that we can predict what is going to happen in future, whether it is near future or far future, whatever that future time horizon is. So that is at the very fundamental level what the AI programs, or I use the term agent, but it really is an AI program or an AI being. They are making all these models to make useful predictions. And then it all can be combined in a certain workflow and architecture where then it becomes a useful tool. One thing, Phil, that I'll just quickly mention, and Ali, is one of our theses in this podcast is this emphasis of how humans and machines are going to work together. And first of all, why is it even important? And how it truly is a Nash equilibrium, an economic optimal situation. So we will talk about, AI over the next, hour or so in the context of a human-centered approach. But I want to make it clear, it's not really that I'm saying, oh, humans are special, we have to be at the center of gravity. It's none of that. It is more in a system, even if humans and AI are considered peers, we will talk and I'll share some of my thinking that how working together allows us to get to more optimal outcomes than either of us on our own can get to, even when AI gets smarter. So I have this very positive, you know, collaborative sort of mental model of how in a business setting, AI and people or AI and business users get to work together to create a better world, a better future for everybody. But anyways, as you guys can see, I get excited about these topics. But okay, so far, competence without comprehension is the message so far.
Okay, Amjad, you'll have to tell us, where do you think AI is today and where do you think it's going? I know you've described this before. Maybe the AI today is narrow AI. If you could kind of go into details about that, to give us an understanding of, the potential of AI.
Yeah, yeah. So I think today we are living in the age of narrow AI, or this era of narrow AI. I kind of, and many people think of the AI journey as narrow AI, uh, general artificial intelligence, and super intelligence or super AI. So uh, one way to think about uh, the whole thing is these types of innovations happen in exponential curves or exponential settings. So kind of the Moore's law that we all know about, it applies to AI as well. And what happens in exponential progress is early on, it seems a bit slow, but since at every time step, it is doubling its pace of innovation and progress, a point comes after which it starts picking up the pace. Now the pace can be, uh, slow exponential or fast exponential, but after a while, that non-linearity, that positive non-linearity kicks in. So certainly today we are in the narrow AI era. And a way to think about narrow AI is where for a given task or set of tasks, uh, read certain radiology images and tell which disease you see or not see, or take a look at a customer data and figure out what uh, pricing strategy to offer to a given customer, or more complicated set of still narrow tasks, drive a car autonomously or semi-autonomously. So narrow AI is for one task or few tasks having competence that for human comparable tasks that humans can perform is at par, meaning the AI can perform progress or can perform at the same level. Again, competence on those skills or those tasks, not comprehension. Don't ask if I'm that AI. Don't ask me yet, how am I doing that or why I'm doing that, but I'm doing it, right? So you can evaluate my performance and all that good stuff. Uh, or it could be a set of tasks too. But then there are also, which we'll also talk today, there are many, even in the narrow AI, tasks that AI performs today that humans cannot. And that, I think, is where the human AI teaming up, even in the narrow AI phase, makes sense. Where the journey Ali is going toward is, and it's anybody's guess whether it is, 5 or 10 or 15 or 20 or 30 years out. But the next main sort of phase will be where we achieve a general human level intelligence where an AI can perform all of the things that it does, plus whatever it is that we do as people in terms of our general purpose solving capabilities, that it can do that as well. So a lot more general purpose problem solving and competence in that sense. One thing that I'll say is real quick on this competence without comprehension thing. If you think about it, we even as people, as I just earlier said, the competence that we have, it's not as if that we have perfect comprehension on the competence that we even as people do. We make up stories, we create narrative, but that doesn't mean that we have that comprehension. Still in this next layer of I don't expect AI to be sentient or conscious yet, the way we are sentient conscious beings. And then sometime later, sometimes people call that singularity or whatever, is this super intelligence stage where uh, it's competence with comprehension and comprehension with consciousness, where now these beings are conscious as well. But I think it's not meaningful to talk about those two layers. We are in the age of narrow AI. So from this point forward in this podcast, whenever we refer to AI, we will be talking about narrow AI, unless we make a specific reference to some of those later stages.
So I think on that diagram that we just saw, there's a reference to saying that there's low-hanging fruit in narrow AI. What are some practical applications for, especially since we have a number of business users on here today, what are some things that people could be doing to implement AI within their organizations, just at a most basic level?
Yeah. So now look, I think the journey from a business perspective first begins with understanding uh, where we are today. So if I am a business user, if I'm a business team, if I'm a department or a company, I need to see what internal self-awareness exists about uh, narrow AI. And do we know, in some proper way, uh, what AI is and what AI is not? Uh, and one place to start there is to identify use cases that can be accomplished today with narrow AI. Now, we'll be talking a lot about those use cases in this podcast, but one way to think about those use cases is, since we said that AI learns with data, to see where we have a lot of good quality data available, or it can be made available. Those areas are ripe for AI to learn useful competencies and become a productivity enhancer, creativity enabler tool for its human companions. But it really all starts with uh, an organization getting serious about that AI is not a buzzword, AI is not Siri, AI is not some conference that we go to once a year. It is a fundamental game-changing technology like electricity and combustion engine and automobile, space exploration, internet, right? So it has to be, so that means then all those technologies, they are overhyped in the short run and underhyped in the long run. You know, so there was a dot-com, bust in the 99, but here we are in 2021, and I don't have to share with anybody whether internet or e-commerce is real or not. So AI is coming our way, and it's going to be an enabler for all kind of new business models and new ways of doing business. It is going to take digital transformation to a whole next level. But it all starts with, okay, are we as a company serious about it? Are we talking about it? Do we have an approach? And then what are the baby steps that we can take? And no matter where we go, Ali, the AI discussion and journey is always going to start with data. Data is going to determine which business use cases or outcomes AI can learn and produce. So I think that would be a good starting point just for a company to say, do we have a way to think about AI? Or is it just a fad topic that some fine day somebody will think about it and that sort of a thing? Now that is where I venture to say companies who would take a thought leadership to say, we need to learn it, we need to get serious about it, they will end up producing sustainable value for their shareholders in the years and decades to come.
Thank you, Amjad. As business leaders look to further understand AI, many describe you as a CEO of a company by day and AI Lego block designer by night. What are those Lego blocks of AI? How do you describe those?
Yeah. So look, uh, if we even think of us as uh, people of how we do stuff that is, considered intelligence, and now we are trying to create AI that is mimicking us or learning from us and that sort of a thing. At a very high level, we do uh, we sense our environment. Then we do a lot of perceptual computing. So we do this perceptual processing that happens not consciously. And then we do a lot of this conscious, you know, awareness and talking to each other in a social setting. So if I create that analog, and that is kind of an example of this bottom-up first principles thinking, and I take the sensing and perceptual uh, computing part of what goes on in our brains, and I call it machine learning, uh, and then all this conversation, and we then talk about what our unconscious mind reports to the screen of consciousness, if I may call it that. And we use all kind of, language and facial gesture and social tools, communication tools to talk about it. So to me, then those two big Lego blocks in the AI of today are machine learning and natural language, and they sort of overlap with each other. They feed off of each other at many levels. What machine learning does, it provides an output for the natural language part of the architectures to communicate or talk about, and then it feeds back. So I think so. It's the so for today's discussion, I would say machine learning and natural language processing are the two big ones. We will further unpack, what these ideas, are here in this conversation. Another one for our future podcast is computer vision. So machine learning, natural language processing, computer vision, in their general sense, are the big Lego blocks, and we'll certainly, communicate along the way what are these topics, architectural components made up of, and all that good stuff.
Amjad, in the most basic way or explanation, what is machine learning? I know a lot of people on the call probably have a very good understanding, but I think a fair amount of people have heard about machine learning, but what are the core principles? Like, what are the steps that go into what makes something machine learning?
Yeah. So machine learning, as the sort of even its name suggests, is learning with data, and it comes in two flavors. So let me just do a little bit of a simplification of uh, machine learning. So let's call it supervised machine learning and unsupervised machine learning. So since the AI journey starts with data, so if you have a lot of data, business data, whatever other data that you have available to you as a company, just the basic analysis of that data to find patterns that naturally occur in the data. Uh, that is a starting point. Sometimes there is a term, Ali, called clustering that is used for that type of analysis. And uh, but so that's a very fundamental. That is a very fundamental sort of starting point. Now, 80% of machine learning today is some form of supervised learning or deep supervised learning that we will talk about, you know, uh, more later in this conversation or in future conversations. But there, what you are trying to do is you are taking the data and then you are trying to map it to an outcome, and then you are trying to create classifications with that. So you are trying to create some kind of color in an abstract sense. So you look at all this data, which you can do analysis and clustering on. But in supervised learning, you say, well, okay, here's all the data on my customers. And then somehow, some of these customers are more satisfied or less satisfied with my products or services. And some of these customers are more profitable or less profitable. Uh, Whichever way you want to categorize them, you want to classify them. But you have that, data available in your organization. That could be an assumption too. So then machine learning is to find an association between all those attributes about your customers or your products and these outcomes, successful product, not a successful product, right pricing strategy, not a right pricing strategy, profit happy customer, not a happy customer. And the goal is, let's say if you learn that function, which is what machine learning is, that map these attributes to those outcomes. And we are not implying that there is a causal relationship between that. Even if there is one, it's not known. This is just a mapping, right? This is a functional mapping. So now, so let's say you have learned that, right? Now you ask a question, you get to ask a question, because we all said at the beginning that the one purpose of AI is to make models. And why do we make models? So that we can make useful predictions. And now we have given, in the context of machine learning, two ways of doing models: clustering and classification. We called clustering unsupervised learning. We called classification supervised learning. And we also said classification is 80% of what AI today is. So in classification, then, you have mapped, in our little simple handy dandy example, customer attributes to happy, unhappy, profitable, non-profitable, whatever those outcomes are. So now you get to ask a question. I'm finding a new customer, and would they be a profitable customer for me or not a profitable customer for my products or services? Well, these attributes will tell you what type of customers to find, because you now know what the success criteria is, what kind of attributes give a high fitness for purpose score for those customers. Same thing for products. You're trying to come up with the new idea, new product. A lot of people in a company come up with all these different ideas, right? Unbound creativity. But which one of them you take to a product stage, which one of them you invest in, right? So then you can draw upon your supervised learning models, these classification models, to say, you know, here, when these attributes are present, the chances of success are high. So you are, in a way, making a prediction about a future that you are trying to engineer, right? So there is one past, there are many potential futures, and you are trying to pick and choose a future that you want, and classification allows us to do that. So now I'll just say this thing for a quick sec. So if I'm a business user listening to this podcast, what does it mean for me? So here, again, the first question is, we as a company, we as a team, we as a group, are we doing any clustering? Are we doing any classifications? If we are doing any such things, are they being systematically done? What type of data we are using for that? What types of mappings we are learning, right? And so just starting with a library of that. And if we are not doing anything, if we look around and we say, we have not done any classification in the history of our company, well, then that is a good starting point. One thing that many companies will find out is the what I call the snake oil effect. So many times, because we live in this era of narrow AI, where I said that all technologies early on are overhyped and over time, underhyped. So today, everyone is an AI expert. Every company is an AI company. So many times you will run into this pattern where somebody will show you a nice looking dashboard and say, this is AI. So that would be an example of a snake oil effect, right? So that a dashboard is not an AI. It could, it may be an attempt to communicate the results of an AI. But here you have to ask a question. Are we as a company, are we as a team, are we doing any clusterings and classifications? If so, what are they and how are we using them? And what is that full loop learning between AI and people on those things? So anyway, so those just on the machine learning stuff, that is kind of how Ellie, I will talk about that.
Actually, we have a question which I think is relevant to this topic. Uh, Sarah was asking, can you share an example about how AI or machine learning can help the retail industry not just survive in this challenging economy, but thrive in a post-pandemic world? I know that's kind of throw it at you, Amjad, but if you have any specific use cases that you think that AI or machine learning is relevant to this particular industry.
Yeah, I mean, look, at some level, retail industry in its omni-channel sense, because today everybody's omni-channel, what we are trying to do is with uh, limited resources, we are trying to take the best possible care of our customer, our consumers, right? And if I'm a retailer, I have a certain focus of what type of consumer needs I am catering to, right? What is my personality as a retailer? What type of a retailer I am, right? But in that retailer consumer setting, you are trying to create an experience today, because we are living, retail is these days all about, it's an experiential economy. We are trying to create experiences and journeys for our customers, right? So there, I think, again, baby steps. So the example of clustering would be, Ali, because I'm going to use fundamental, basic first principles and going to keep back to the concepts that we are talking about. The clustering would be, look at how your customers and their attributes are naturally organized, and what are different types of uh, customer groups and what have you, right? Uh, the classifications would be to be able to see uh, whatever that happiness index is, how your consumers, your customers, are mapping to that. And that just informs you a lot about uh, who my customers are, what it is that they like about my offerings or these experiences that I'm creating for them. And if I were to engineer some outcomes, how can I do something? So that is something that you can do with doing some basic clustering and classification. Now, where do you actually take that is whether you say, well, I'm going to make sure this segment of my, customers, which is a very important segment for me, it looks like I can take care of some of their needs in a better fashion, whether it is better assortment or making products available in a more positive experiential fashion. Whatever that is, you can then focus your limited uh, dollars and capital on that. If you go sort of behind the scenes in the supply chain planning and demand chain planning side of things, so there then you can get into even more fundamental layers. These are the lower layers of the stack now, where you can say, well, okay, I all these higher level experiential problems, by the time they come to my fundamental layer of supply chain planning, demand chain planning, assortment planning, those types of things, I am solving, you know, a complex equation where I'm trying to, with limited of an inventory investment that I can, I'm trying to achieve, you know, less out of stocks, and I want to make sure that when my customer needs something, I'm able to provide that, right? With frictionless commerce. Uh, and you have your own goals there at that layer. You are trying to achieve certain sell-through or efficiency goals and what have you. So you are solving that. Uh, now, uh, one thing that I will again say, first principles thing, Ali, is you need the data organized in the right fashion for any of these things to work. So no matter which company, which segment, retail or some other segment, uh, the journey of AI will always start with, do I have the right data properly refined, aggregated, unified, kind of as if I have a digital twin of my physical enterprise that is receiving all this data where all this advanced analytics and simulations can happen. Uh, because at some level, when you bring clusterings, classifications, predictions all together, you are trying to run many forward simulations about the future because you are trying to create, using AI as a tool, you're trying to make certain future scenarios happen. So in order for you to do that, I find a digital twin of a physical enterprise as a useful architectural metaphor and analogy. And it takes more than that because it requires a physical manifestation of how to create those twins. But so it starts there, uh, it starts there with the data. But those are the types of use cases, Ali, that toward the top of the pyramid, it's all about, knowing your customer and are you creating the right type of experiences? And then at the lower layers, more fundamental layers of your business, are you rightly organized to make those things happen? And we can certainly in our future conversations, we can go a lot deeper into a very specific use case. But here we are today in our first episode, we are just talking about, we are laying the groundwork. So that is kind of how, Kelly, I would answer it. I think people who are watching, they probably would have noticed by now is I talk too much. So I need to talk less. So I'm going to
It's
start
good.
talking.
That
I'm going to
question was
start
good
talking like
foreshadowing for future episodes as we want to get into the nitty gritty details about use cases. But um, Bill, I think you had a next question.
Yeah, thanks, Ali, and thank you, Amjad. I think this would maybe be a good time for us to share an exercise together. And you mentioned analogies, Amjad, in your last comment, maybe showing us a practical exercise where we can see the power of some of the things that we're talking about today.
Yeah, no, I think that is a good thing. So I think let's do something with classification. So we'll do a little fun thing together where we'll use our minds to uh, do some effortless uh, classification and see what happens. Hopefully, it will generate some good interaction here. So let me share my screen. Give me a sec here. And alrighty, so let me bring up. Okay. Alrighty. Can you guys, Phil, Ali, see my screen?
Yes.
Alrighty. So, okay. So we as people, color plays such an important role for how our minds effortlessly do classification of colors. So I found this interesting example, which a few months ago or a few years ago with COVID, losing a little track of time there, it generated quite some internet viral activity. So the universe got too excited about this dress. So this dress at the top, people were thinking, oh, it's white and gold. No, it's black, blue and black. And so I'll let you guys I will let you guys sort of poll on what do you guys think in terms of, is it blue and black and is it white and gold? And while you are doing that, it is your visual cortex part of the brain that you have no conscious control over is computing it. And then your language center of the brain is saying it's blue and black. 75% people are saying in this audience it's blue and black. 23% are saying white and gold. This top picture looks pretty, white and gold to me, right? So it's all relevant in that sense. But let's do this funny experiment here now. So I'm going to just, uh, take a slice of this dress. So I'm not doing anything crazy. I'm just going to make a point that just by changing the context of this, see what happens. So I just picked up a portion of this image. I'm going to do a copy. I'm going to do a paste. So here is that thing that I just picked from here. To anybody who thought it is blue and black, it is still looking blue and black. Anybody who thought it is gold and white, it's still looking gold and white. Now I have two sort of, contexts here, a dark day or a gray day context and a uh, bright day context. Same image, see what happens. So here, if I bring it here, so here it would be very difficult for you not to see gold and white, right? So let's see what everybody is seeing here. If we do this poll again, please jump in and tell us, what do you see now? Uh, like I said, that context matters, right? So this is classification that your brain is doing. You have no control over it. And I'll show it to you here in a sec. So, okay, so we make the point, that almost all of us see this as white and gold. Even those of us who saw about 2/3 of us saw that as blue and black. But now see what happens here. I just brought the same pixels here, and now I think it
I'm
would
back to blue and black.
it is all back to blue and black, and this is our mind doing a classification. And now let me just show you how no control that you have on this situation, right? So blue and black, gold and white, blue and black, gold and white. You have no control on your mind. It is just reporting what it is computing. That is what the classification is. And if I go back to the context-free thing, then you're back to anybody who originally saw blue and black gets to see blue and black. Anybody who originally saw gold and white, see gold and white. But here we all see gold and white. Here we all see blue and black. Okay, that is a classification that our mind is doing without any conscious control. Conscious control is just reporting that, right? So if we now just stick with that and apply it to the narrow AI, the machine learning, where we said that 80% of today's AI is uh, uh, classification of one sort or another. So these types of problems persist in narrow AI too. Context matters. And you can make classification errors. It is not perfect. We all are people, and yet we see here stuff differently. Here we see it the same way. Here we see it another way, but still some single version of truth here, single version of truth here. We are split here as people. Now, if you think about it, the part of the brain that is doing this classification, since we have no control over that, isn't that competence without comprehension? If I ask, how is brain doing that? unless we have some neuroscience PhD uh, online with us, we would be hard pressed to give an explanation of comprehension. But we have the competence to do it, and we do these kind of things all day long. AI, we teach AI to do classifications as well. Certainly, you need a lot of high quality labeled data for AI to learn classifications. But anyways, I thought, that you will find this little uh, example handy dandy. I, at this point, need to also share that a lot of this conversation that we did today, uh, I need to recognize uh, Daniel Dennett, uh, who is a consciousness philosopher, uh, Joshua Bach, and many other people, too many to name. Uh, but uh, anything that I'm saying today, these are not my original ideas. I'm just a humble student with a passion for curiosity and learning and how to apply things into a business life. So no, back to us. I hope that we all found this little example interesting because if I recall, uh, when that viral phenomenon was going on, the universe was split on which one is it, and the it depends upon the context. And I think for most contexts, it is blue and black. But now we saw that there are contexts in which it can be gold and white as well. Uh, we just saw that.
Oh, gold and white. I'm Chad. One going back to our questions, I think we have time for maybe one or two questions. One question from the Q&A section. Someone mentions that AI is being used in the industry at a level that we as consumers are being subjected to engineering the future on different levels. The question is, what are the industries that you see AI most being used today?
Yeah. So I think uh, uh, it is at some level, it is everywhere. However, the level of adoption may be different and what have you. So in the consumerization culture where we live in the age of smartphones and apps and whatnot, any app where there is a camera function involved, an AI is at play. Now I don't have to, talk about the limited narrow AI capabilities of Siri and Alexa and the like, but just in general, any such you know, consumer facing devices and apps have a lot of, narrow level AI in that. Now, the big money making engines out there, the ad engines, how big platforms like Google, Facebook, Amazon, they target their customers, their users, their consumers, big tech, as they are called, they are very heavy users of AI to manage their relationships with their consumers, right? So even platforms like YouTube or other platforms, Twitter, right? But if you could leave that aside and just talk about where maybe the benefit is there uh, in the healthcare arena, a lot of diagnostic applications in radiology are using AI. Uh, in industrial applications, a lot of tasks that are either difficult for people or create hazardous, challenging environments, robots certainly, they need brain and a brain by default have a lot of AI in it. So industrial applications today are using lot of narrow AI as well. Businesses just have started using for their core uh, manufacturing, distribution, supply chain, or demand chain, those types of operations have just barely started using narrow AI for that. Certainly, some companies out there are using AI uh, how to create these experience journeys for their customers. A lot of other applications that are out there still in their early stage are in preventive maintenance in a plant setting or a machine and that kind of a thing. Uh, Certainly, the drug discovery process is assisted with AI as well. So wherever you have a lot of attribute rich data and you can label it with certain outcomes because you have all that historical data, it's ripe for an application of uh, machine learning. Uh, Tesla's sort of full service driving computer or Waymo's autonomous software, they are examples of AI, not perfect AI, uh, uh, but those are examples of AI there. So when you are uh, driving your uh, car that has some such AI in it, uh, you'll feel it because it will try to, if you have the steering and it is on and you're trying, you drift, it will bring you back. You will feel the torque as if, somebody did that. Uh, Still early days of AI for most meaningful applications. And some industries and companies are ahead of others. But it all boils down to, uh, for a given company, their data readiness. And in any sort of AI setting, the first sort of thing is, okay, how can we get some part of our data organized where it gives rise to AI to happen? One last thing I'll say in today's podcast is AI at STEM level is nothing other than advanced information processing. So, okay, so it is just another tool, another way to process information. Uh, it is just that it is we don't have to explicitly describe requirements and those types of things, and you can just let uh, an a machine or an algorithm directly learn from the data without a human in between. And then you're freeing up that time for your human colleague. And then hopefully the human colleague, the business user, can use his or her time in a very creative way. So that is where then the AI and business users working together, AI can bring a lot of automation, you know, getting a lot of the chore work done, freeing up the business users' time, but bringing as a good assistance all the intelligence to the human user or users where they can make or take a smart decision. So that's kind of the uh, what I would say answer, Phil, to that question. And with that, Phil, back to, I know that we are almost at the end of our time, back to Ellie and you.
Yeah, we are almost at the end of our time, but I think you hit on the last kind of question or discussion point that we've been seeing in the chat, as well as just the overall topic of this podcast. And that's how are humans and machines going to work together? What's the future of work? I think you touched on it, just empowering humans to not do the busy work. And is that human centered AI? Or if you could just kind of touch on that as our last point.
Yeah, like, so I see AI's main job is to make our conscious life as people, as organizations, more meaningful, more joyful, allowing us to really leverage our creative talents and to be able to express our creativity more. That is where, I see AI being a tool that can be really, really helpful. Be sort of an extended mind to its human counterparts. And I know that in our future sessions, we'll be talking about concepts like extended minds quite a bit, but it is in that setting. So today, I think what I would say is the main purpose of AI as a tool is to bring value and meaning to our lives. After all, we are the ones who are creating the narrow AI. So
Great. Well, we appreciate everyone's attention and questions that you've asked, and we look forward to our continued dialogue in our future podcasts. If there's any recommendations for any future topics that anyone would like us to cover, please do let us know.
And I will say, I just saw one coming, and I think it's a great topic for a future podcast. Because whenever I hear all of this talk about the power of AI, I do get a little scared. And what should we be scared? Is it dangerous? So, in podcasts to come.
All right.
thank you, everybody.
Take care.
Looking forward to our future conversations.